Hello, welcome back to my channel. As you know, yesterday I tried to solve the problem named longest substring without repeating characters. I already submitted a correct solution. However, it's slow, so I was I tried to find a faster solution. Yesterday I came up with the solution using the an array named lattice index, but it still has a problem. So before we go into the detailed algorithm, we have a look at the problem again. The problem is that given a string, find the length of the longest substring without repeating characters. For example, here we have A, B, C, A, B, C, B, B, and the output is 3 because the longest substring without repeating character is A, B, C. With example 2, we have a string of 5B and the answer is 1. And with this example input PWWKEW, we have the output is 3. So let's come back to the solution I already had yesterday. I use the for loop run from the beginning of the string until the end, and I use the hash map of the current char to see what is the latest index of the of that character. And whenever I find the character that is repeating, I stop there and calculate from the index to the lattice what is the max length. So for example here with the A, B, C, D, C, E, F, B, this, this is the example that the test case that this algorithm ran wrongly. So here I put when I go to iterate at the first index is 0, I put here A, the lattice index is 0, then B, I have 1, and C, I have 3, D, 4, and then I read C again. So C should be changed to 5, and I set max length to 4. Oh, sorry, 5. C, oh, sorry, let's do it again. Max length is 0 at first, then A, 0, 1, B, 2, C, 3, D, and then we see C again. So here C is 4, and because it's repeated, I set the max length from the latest index to the index. For example, here I will character whether the char index minus latest index of that current char is bigger than max length. Then I get it. So here I have the char index is 4 and is C. So the char index 4 minus 2 is bigger than max length, so I put it 2 here, and then I replaced the lattice index of C to 4, and then I run to E is 5, and F is 6. And then I see B. B is 7 here. So I calculate from child index 7 to the lattice index of B is 1 and it's 6. So 6 is bigger than max length, so I put 6 here. But in fact, between B and B, there's a couple of C. So that's not a good solution. This is the wrong one, in fact. So today I have to think another way to solve this problem that can solve the problem of the two C between. And I am thinking about maybe we should use a head. So the head is when we start of the substring. So for example, if I find a C here, it is clear that I cannot go past the previous C because it will contains 2C in a substring. So clearly I can move head to 3 in this case. So and the max length should be calculated from the child index backward to head, not to the old lattice index. So now we will start to do this example again with the head and max length and child index. Okay, so now we run child index 0, we put it to A, 1, we put it to B, 3, we put it to C. So child index is 3 now and has still remained 0 because we do not have any repeating character. And then D is 4 and child index is 4. Now when it comes to C, it's 5 and it's C. So it's a repeating character. And because it is a repeating, I already see a C here. So the best substring I have, the longest substring I have until now, will be from head, from 0 to the character previous of the child index. So to this one, from 0 to from A to D. So currently child index I'm at the 4, and so the max length I have would be from child index minus head. So I have max length here is 4, and I will put I have to move the head from 0 to the character after the C because I cannot have any substring start with C again. So I will move head to D. So it would be the O lattice index minus 1. So it should be 3 here. No, sorry, it's 3 here. And I have to replace the lattice of the C to 4. Okay, so now we run to 5 is an E not yet in the lattice, so we put it here. F is 6. Okay, and then B, we see B again. And we find that we already have in 1, but because the head we only calculate from 3. So in fact, we don't care about that. It's not in the max length. So it's okay to still put it. The child index is 7, and then we have to replace the lattice with 7, a b with 7s, and it's the end of the string, so we have to check if is child index is at the end, and that character at child index is different from character at head. So we have to calculate it. We have to count from head, from D to here. And because it is at the end, we have to um, add 1 to this. So we have to calculate plus 1, whether it's, and compare it to max length to see. So in this case, because 7 minus 3 plus 1 is 5, is bigger. So we have 5 here. And the longest substring you has go from D to B. So that's how it works. So now I will implement this, update it in my code. Let's see. We need another. No, need this. We need an integer of the head is 0. Okay, so we run through it and we have this. So if that contains keys, we have to think about whether we have to calculate this not from the lattice, we calculate it from the head. And then here, head, and we replace it with the lattice, and before that we set head to the lattice index. Of the current character plus 1, and then we will replace it, and I remember that we have to think about whether the head is smaller than the lattice or not. Because if the head is bigger, than that, it doesn't make sense to calculate the max length. but it doesn't make it wrong. So okay, we can do it even we know that it's not um, a better result. And then here we also have to calculate that if the character go to an end, because we don't have any don't have any break in the for, so we always have the k index run at the end, then until the end of the string. So here we have to check if the character at jar index is different at jar at head. So we have here the index, yes, we have at jar at head is different from s jar at s length. Or in this case, we may choose jar index. Then we have to calculate. Okay, let me comment this one. Oh, it is another test case. Before I want to say more a little bit about this, that here I have to put each child index -1 because here it's after that for it run to s length, and because the index is smaller one smaller is s length -1 is the final index of the string. So I have to put -1 here, and here I don't have to +1. So let's take this to the test case. So output is still 6, which is not what we intend to do. Let's see why it can be 6. I will print every time it updates the mark length. Inside loop and max length and child index and head. And here we have a CN. Okay, I think it's better to leave it like that so we can see what is the value of the max length before we update it. Here we have inside loop 0, 3, 0 is good, and we have 0, 4, 0. Why mark length is 0 again? We have to see. Mark length should be 0 only once. Mark length here is 0. So a 3 here is D. It should not, update the max length. So there's a problem here. So we have char index 0, current char. So we will print to see which key is check the key, and we have to see which character is considered the one that is repeated, because here we only have with the index 3 is D, and D is not in the latest index first. So it's supposed not to run here if the current child is D and the child index is 3. So let's see how it happened. Here he have checked the key. So it is A and 3. Oh, okay, that's the problem. Oh, we run to test case. That's not, it's misleading. Okay. Here we have check the key C4. That's good. Inside the loop is 0, 4, 0. That's good. And then again, check the key is B7. And at the end, we have, oh, so we have the, at the end, it is max length is already 4 from this one. It's good. And the child index is 8. So that is at the end of the length is good. But here, the head is 2. That's not correct. Because in this one, head should be 3. So let's see how we did with the head. So we get the current char and -1. So at 4, here is 0, 1, 2. So 2 minus 1 should be 3, but it's 2. So we have to check this one. Okay, we don't have to check the key again. We will move it here to check the head. Check the head. And it should be after the command. Okay, so inside the loop is 0, 4, 0. And we check the head, is C3. Oh, and here the head is set to 2 again when we meet B, and that is the problem. So we only update the head if the lattice is bigger than the current head, because we do not go backward, we only go forward. So we need another if here. If is this, so so it's supposed to run well now. Okay, so it's look good. I will try other technique or other we have here with the AK. So this is the empty string. This is string with only one character, and this is the string without any repeating character. So it means that the substring, the result should be the length of this string. Okay, so all the Desktop this program run well. So now I will clean it. I clear all the example here, all the system print here, and yep, run it again to see there's no std out here. Okay, so no std out here. I will submit it to see. Oh, so it's much better now. It's faster than 80% of Java online submission. Um, so it seems like a good solution. However, it's not the best. So I will try to make it smaller so that you can see all of that in the same window. I will try. I'm not sure whether it works. Yeah, it's difficult so that I guess you cannot see all of that in only one window. So I will post it to see. But the most important thing is that we use only one for loop. We use the head to calculate where we should start. Now I will see what is the best solution by use that solution type. Okay, we have approach one brute force, and that one is O n power 3. Oh, I okay, so it's so bad. Approach 2 is sliding window. It's kind of our first our first algorithm is O n power 2 square, O n square. So yeah, we don't care about that. And the final one is sliding window optimized using hash map. It seems okay. Let's see how it works. So they will using a set of values is it define a mapping, so it's duplicate in the range. It sounds similar to what we have here. Character integer, so it's the same with the lattice index we have. It contains key. So it's the same. So about the algorithm, I think it's the same. So most important is the technique, so that we don't have to check this one. So it uses a for with two index. Z seem to be the child index here, and E seem to be the head we have here. And they use the math marks. So for example, like here, the when says max length is math max and max length. So no need to if. Okay. And same with head. It would be math max and head. And there's no replace or we put. So mean like here, no else should be here. And head will be the previous one, not from the next one like me. So it it would be, oh no. But in this case, I don't see the what happened if there's no repeating character. because here it only happen if map contains key strc. So if there's no repeating characters, this solution may wrong. So I guess it's only the idea, it's not the real solution. Let's check whether this new code with the math run or not. It's run. So let's see how fast it is. A little faster than 89%. I guess the other may not have this one. But because I don't have the test case applet code, so I'm not sure whether they have a test case with all different character or not. So yeah, I think I'm satisfied with this solution. Thank you for being with me and see you next time with the next problem. Bye bye. Have a good